Welcome to chemistry. I got told to do grade 12 chemistry, so I'm doing grade 12 chemistry review. You have a sheet like this. You can do this on your own if you want to. If you don't want to, I'll walk it over. Now, let us read. For all my ladies in the audience, I'm so sorry. Let's start. So you have this reaction. Magnesium plus 2 HCl converts into hydrogen gas and magnesium chloride. That's fair. What could you look at for the reaction variables? Remember, you have something divided by the change in time. Change in something divided by the change in time. So what could you do? To create a reaction rate for here, it is simple. Reaction rate is name the mass of magnesium, the volume of H2 produced, the decrease in HCl, the increase in MCl concentration over time. All of those work. You can use that for the other one. Here are a couple examples I did. Next, you do the same thing, you just list what it is and why you're doing it and how you're gonna actually check. Like this one, again, you can read this yourself. The decrease in volume from these all take up the same amount of space, but there's 4 of these on this side and 2 of these on this side. So if everything reacts, there will be half the amount of volume in there, assuming that there's equal portions and that everything reacts. Next, you have this, which is simple, just math it out. Total change is 20 seconds. Total change in this is 0.01, but it's easy. There's this, which is a curve, probably not that steep, but potato, potato. The concentration depletes rapidly at the beginning, but slows down as there's less concentration to react. If that makes any sense, good for you. You know chemistry. I don't like going on rants, but I have to do this. So thanks, Julia. You're making me rant. Yeah. You might think that's a contradiction because I do only rant on this channel, so I'm sorry. Anyways, this is a dumb question. It's basically saying the amount of collisions possible. It's 3 times 3. Simple. Suggest 2 ways that, okay. In a room filled with O2 gas, explain why the reaction between H2 and O is so slow as to be unnoticeable. Because of the high activation energy. The turning H2O into O2 is kind of difficult because you need 3 molecules to react. 1. Then there's also the fact of the high reactivation energy, making it slower. So your graph looks like this, with your activation energy here. So there's only like the tiniest little percent. If that makes any sense. This is the distribution of how many particles on this side, temperature on this side. Higher over, the further over to this way, the hotter it is. Over here, colder, until absolute 0. Nothing is at absolute 0. 0 particles, the amount of particles, blah, blah, blah. Then it goes like this until it's about here, which is the average temperature of the particles-ish, or where most of the particles are, and then the averages, yeah. But then it almost flattens out here. If the activation temperature is around here, you miss everything over here and only take the tiniest bit that gets over that tiny area. Hence, reaction slow. If that makes any sense, we're going on to the next one where it is visually described. This is what I'm talking about. A bush. Now you just guess how much is on either side. There's that. Okay, now, question. Is this endothermic or exothermic? Answer, exo. Why? Because potential energy is higher on this side. Therefore, when it releases that energy, there's more energy out than you put in. Hence, exothermic. Endothermic would be opposite. Less potential energy on this side. So when you put the energy in, there's more energy in the molecule and therefore less energy outside, hence endothermic, takes energy in, exo puts energy out. However, the change in heat is different. For this, it would be negative H because it goes lower. The H represents potential energy, or the change in potential energy, basically. So negative H would mean exothermic, meaning losing potential energy to kinetic energy. The opposite. Sense? Perfect. Next. Oh, and don't forget to put those like line things, like say that this is the EA for the activation energy for EAF, or the forward. This is the reactivation energy for EAR, backward. This is the change in H. Say it's negative for going forward. In this case, it would be, if you were going this way, it would be positive, but potato. Then you got a bunch of questions. Trust me, you can do these. If not, use ChatGPT. This isn't an assignment, though I know some of you use it on assignments as well. Come on, guys. Honestly, fair though. But DeepSeek's better. Bye. Anyways. Yeah, that's about what all this is. Okay. Effectively just repeats itself for the rest of the time. So, have fun on the exam, test. Love you all. Mwah. Goodbye.